Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod. In the last session, we have come to know what a signal flow graph is and what is the terminology regarding signal flow graph. Today we'll see signal flow graph algebra. In this you have certain rules. Rule 1, you have two nodes A, x1, where the gain here is A, x2 is the node. Incoming signal for node 2, product of the signal at the previous node, signal is x1 and gain is nothing but A. So product of the signal at the previous node into gain would give us the incoming signal for the next node, that is x2. For example, if you do have nodes like this, x1 say, x3 and this is x2 say, the gains here for this is A1 from x1 to x3, from x2 to x3 we say A2, then x3 would be the combination of x1 into A1 plus A2 into x2. This is A1. This is the input signal for x3. Now the second rule. Now if we have cascaded branches, say for example, this is x1, gain here is A, node x2, and this is x3, and gain here is B. This can be simplified as x1, x3, product of A, B. So cascaded branches can be combined to give a single branch where the gain is equal to product of individual branches. The third rule, when you have the parallel branches, say x1 is the node, x2 is the node, A, B, x1, x2. This can be combined to some, and this one would be A plus B here. Rule 4, when you have a mixed node, this is x3, this is x2 and this is x1 say here the gain is A and this is B, then you have another node, the gain is C here. You can eliminate the mixed node here where you have incoming as well as outgoing branches here by representing this way, where x1 is the input, x2 is the another input, then x4 is the output. A into C, this total path, okay, this would give us the gain here, B into C. Rule 5, we can eliminate loop here. X1 is the node here, from x1 to x2 the gain is say A here, and then followed by x3, gain is B, where you have a loop starting from x2, again you end up with x2, then that would be a loop, then the gain is C. We'll try to simplify this, x1 to x3, x1, x2, x3. From x1 to x2 A, eliminating this B by 1 minus B. We'll combine this into a single branch, this into this both are in cascade now. So AB by 1 minus BC. We'll see the proof here, x2 equal to AX1 plus CX3. The signal coming to this point is nothing but A into x1. Again there is one more signal coming to x2, that is C into x3. x3 is nothing but B into x2. Replacing x2 will give us x3 equal to B into, example say this is 2, 1. We are replacing 1 and 2. AX1 plus C into x3. x3 equal to ABX1 plus BC x3. x3 minus bc x3 will leave us ab x1. Taking x3 common, x3 1 minus bc equal to ab into x1, x3 by x1, that is ab by 1 minus bc. This is the transfer function for the reduced form after eliminating the feedback loop or the loop. Here also the same way, loop. We have all the algebra and we know all the terminology, but before solving this particular approach, we'll go for one more concept, that is knowing the Mason's gain formula. Now we are supposed to know Mason's gain formula because this is the tool used for reducing the signal flow graph and find the transfer function. This transfer function is nothing but the overall gain, output by input. Its overall gain is given by T equal to 1 by delta sigma k pk delta k. T is nothing but transfer function of the system, or overall gain you can say. Pk is nothing but forward path gain of kth forward path. Pk, forward path gain of kth forward path. Delta 1 minus sum of individual loop gains plus sum of gain products of all possible combinations of two non-touching loops minus sum of gain products of all possible combinations of three non-touching loops plus and so on. And delta k is, you are supposed to find the delta for the part of the graph which is not touching kth forward path. For reducing the signal flow graph and finally find the transfer function or overall gain, you are supposed to use this Mason's gain formula. If you do have any queries, please comment in the comment box below. Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.